All right. Thank you for having me. It's actually so extremely strange to see like all of these Arweavers in real life for the first time. It's been like 7 years that I've known a lot of you online, and it's just surprising that you're not all like cartoon NFTs. But yeah, I'm gonna do a quick intro on Alien Compute with Hyperbeam, and I'm gonna get into demos on it. I've bravely prepared 2 live demos, um, which probably not going to work. So let's see. But yeah, ultimately, I'm going to be looking at Ultraviolet, which is an app chain that uses Ethereum, the EVM runtime, and it's encapsulated inside a Hyperbeam device. And I'm looking at kernel execution functions, which are able to run like GPU shader functions inside of Hyperbeam devices. So my background and where I came from is Decent Land Labs. So we're like a team of researchers and developers that have been building on Arweave since 2019. We started building in the pre-SmartWeave era, even looking at how we're going to, bring compute to Arweave. Obviously, AO came along and solved that problem for us as well. But along the way, we've had a messy history of building different bits and pieces of compute layers, and kind of ended up at a kind of merging of the EVM and Hyperbeam and Arweave. Right now, what we're doing is building Load Network, which is the first EVM L1 that has native integrations with Arweave at pretty much every level. So it settles all of its data to Arweave. It has pre-compiles inside the Solidity contracts so that you can actually push and pull data to Arweave from inside the EVM smart contract interface. And what we are kind of bringing next is Hyperbeam modules that can actually offload all of the stuff that Solidity clearly can't do and is never going to be able to do to something that is perfect for it. So that's really what we're looking at with Hyperbeam. One of the sort of things is, obviously, you can literally put anything inside a Hyperbeam device. We have experimented with a few things, and a couple of them are MVPs that are actually ready to check out. But I mean, it's also the question of like why the EVM. A lot of AO bulls, maybe are bullish on AO because it sort of solves the problems of the EVM. But really, when you look at kind of what is out there right now, it is the way that people are mostly interacting with dApps and interoperability. It's mostly where the money is, where the dev tooling has been for many, many years, and it's got extremely vibrant open source communities. So that's sort of why we chose the EVM, as it's the on-chain lingua franca. Okay, but yeah, so we at the launch of AO, we didn't actually sort of start building on it. We thought, okay, well, we're very Arweave aligned, but we don't really see how AO actually fits into this stack. When Hyperbeam came out, my CTO Rani started getting wild ideas. He, within a couple of days of Vitalik posting about how that Ethereum is going to become RISC-V, had encapsulated RISC-V into a Hyperbeam device and was running that. The next kind of pieces that we're looking at is like how can we do, more esoteric VMs like Cairo, and much more esoteric things like kernel functions. We are sort of putting this idea under the umbrella of alien compute. It's basically things that have never existed on chain before and are enabled freshly by Hyperbeam. This would be alt VMs and all of these strange kind of GPU things too. The way that load fits into this is obviously it's the sort of the high throughput Arweave backed EVM L1 that has pre-compiles implemented in it that can interact with Hyperbeam devices. So you can obviously like hit Hyperbeam from the EVM smart contract level. One of the things that we sort of focused on with Load Network was, Arweave has infinite data scalability. The EVM is, in most implementations, a calculator as how like sort of low bandwidth that it is. So what we needed to do sort of at the very outset was focus on making load as high capacity as possible. Built basically to be a hub for app chains that store all of their history on Arweave and have native access to be able to do data-intensive sort of computation using Hyperbeam and settling the results of that computation to Arweave. So I'm going to try and do this demo. See how this works. All we have here is a playground where you are able to interact with the ultraviolet app chain, which is a Hyperbeam device. Let's see if we can get all these functions done, and I will even create a Berlin token airdrop and send it to everyone that has previously interacted with ultraviolet. If you haven't, then sorry, and also you can probably go on your phone quick and do so. So yeah, this is now just going to deploy a new ERC20 contract. It's there, it's in the transaction history, and if I run airdrop this token, we should be able to see this transaction history pane populating. So these are like AO standard messages that are running on a Hyperbeam device. So that is a proof of concept for how you can put the EVM devices inside of Hyperbeam. And we also have destroy this asset, which is a glitch art generator based on kernel GPU functions. It uses a web GPU shader. Yeah, we're actually gonna mess with DumDum. So at this point, you can see the load hash has come in, and that means that it's already done the computation and the glitching. We're just waiting for it now to mint it as an atomic asset. Then we're gonna check it out on Bazaar. There it is. We can even re-glitch that and basically recursively run a glitch process on that. But yeah, we can now go over to Bazaar, where this should now be a tradable asset. I hope. So it was Bazaar that fell apart in the demo, not me. Anyway, you. Where are we at now? So yeah, I've explained the kernel execution machine. This really could be applied to anything. A lot of people in the ecosystem are focusing on AI. I think interesting, simple, self-contained use cases like image processing, audio manipulation, physics simulations, things like this can all be brought on-chain properly and accessed through an EVM environment for the first time, which is like, going from Solidity being barely able to do simple things sometimes to being able to access like the power of what Hyperbeam has. So we've destroyed the assets. And next, yes, so really we're continuing to look at what kind of VMs we can bring inside of Hyperbeam. The reason that we're looking to do this is obviously to sidestep the native limitations of Solidity, and we're also looking at how to bring kernel functions like CUDA online as well. We are on Twitter. And on GitHub. And you can find the load HB repo to see all of the custom sort of Hyperbeam devices in our fork of Hyperbeam. And thank you.